I managed to find some more of these little pin jumper thingies, so I think I'll give these a try at the different stepping rates, because it was suggested to me in the comments that this would give me smoother movement and it maybe wouldn't vibrate the little lock nut thingies so much, the lead nut thingies so much. So let's give this a try. It's on quarter steps at the moment, so I'll just move it. I'll just try the x-axis. I'll move it back and forward a little bit on quarter step, and then I'll change it to 8th step and 16th step, and we'll see the difference. I thought I'd make a little test script for this so that we can hear the sound from the same movements each time. It will let us compare them a bit better. So it's just a few movements like that, 15mm each way to begin with, and then you can see it there. And I've had a bit of a problem with this in that I had the wrong line ending type in the file. So if you're using Notepad++, you'll be able to set the line endings like, where is it? End of line conversion. And the one that's grayed out there is the one that I have chosen at the moment, Unix OS X format. So this is quarter steps. This is 8th steps. And this is 16th steps. I've been playing with the acceleration settings and the feed rates here. So I increased it from 500mm per second feed rate maximum to 2000, and I increased the acceleration from 10mm per second to 50, and that gives us this. Which is quite a bit more sprightly. I'm not sure if it can go a little bit further, but I'll play around with it some more. This should make it a lot faster to draw. But does it affect the accuracy? Let's have a look. I'll run that again. The same. That looks alright, doesn't it? The pen seems to be drawing nicely today. It's not missing any spots. Yeah, so that's much better. I like that. I think I'll just leave it like that. It almost seems like when the pen is moving faster, it helps the ink to come out better or something. It certainly sounds more professional, doesn't it? And I checked these motors, and I told you already that the one doing the x-axis was quite warm, so I changed the current limiting setting from 1.8 amps down to 1.4, and now it's just getting a tiny bit warm. I've been trying out the chili pepper application for doing this. It's pretty cool. It just runs in the web browser, Chrome web browser of course, and it's got a nice graphical display which updates itself in real time, and you can do all the jogging and making settings. I think you can actually change the Gerbil settings in there and save them, and then you can have down here you have an interactive G-code thing, so you can type in G-code commands and you can see the feedback from the Arduino. And up here we have something which lets us step to a particular line in the G code. And also in here we have something which lets us, if I control click here now, it's going to XY jog to that point, which is pretty cool. And then I can also just do go to 0 and 0 out, and all of these useful features, and of course jogging here. Like that. So this is pretty cool. So I don't think I'll be using the plain old G-code sender much longer, because this is a lot more convenient. Oh, and the other cool thing is you can just drag and drop your G-code file onto here, and if you're not changing any other settings, then you just hit the play button and play it. So you can switch between them. When you're testing stuff, it's really good to be able to switch between different G-code files and test. See, I'm just doing a few little short lines here, but I'm changing the file a lot, so I'm reopening it a lot, which is, well, it's quite nice to be able to just drag and drop it on there and then hit the play button. So if I hit the play button now, you'll see this little pink thing moving around, and you'll see the current status updating there. I set the plunge rate to a very slow speed there, just that I could check that it was actually being reflected. And it looks like all the settings that I'm making in the Estelcam. So I've been playing around with the plunge rate and the feed rate and stuff like that there, and it all seems to be working as it should. I'm starting to get a bit sick of these wires being in such a mess and also quite short. So before I go any further, I'm going to do something about this, make them a bit tidier and a bit longer. All they are at the moment is the motor that comes, the wire that comes directly with the motor, which is only about 30 centimeters at the most. It goes onto one of these, which is, I think I'll still have to keep this because this is how it connects to the driver board. It's just a servo cable connector with an extra single DuPont pin female thingy on there. So that will stay the same, but in between it I've decided to put some of this wire. I'm going to have to use two lengths of this, or two parallel runs of this wire, because there's only two connections in it, and it's probably a little bit thicker than it needs to be, given that the wires on the motors are quite a bit thinner. But better to be too thick than too thin, I suppose, and just in case I do get some larger motors that use more current in the future, it might be useful to have some thicker wires for it. And I've also got some of this fancy pants expanding wrap, whatever you call it, to go around them just to keep everything tidy, so that's what I'm going to do now. So it's going to end up like this. It's quite a bit tidier overall, except this end I don't like very much. It's still got this funny thing on it, but I mean, what else are you going to do, because you've got to plug it into these pieces there somehow. This is the spindle that I'll be using. It's about 5 centimeter diameter and takes an ER11 bit. Well, I guess I'll just show you these specs here. Not really that cheap. I actually did get a small motor that's described as a engraving thing, and it has a little drill bit that you can use to attach to it, but when I got it, it's just one of those motors out of a radio control car, and although it might have worked for some very, very tiny stuff, I wasn't very impressed with it overall, so I thought I'd spend a bit more and get this one and have something that could do some decent cutting, let's hope. But I wanted to rant a little bit about one of these pieces that's included with it. So it comes with the power supply and the speed control potentiometer, and this bracket here, which is used to clamp it onto your machine. And I thought, oh, that's great, I'll just be able to use this, but this turned out to be a piece of crap, to be honest. So this is it here, and by far the biggest problem was that these holes in the bottom are not even in the right place. So you can see just by eyeballing that those holes are not straight, they're not in the same line this way. And there's more distance between here and the top than there is there in the top. So you can't get bolts to go down into the holes that I had on my plate, presuming your holes on your plate are straight. This side's not so bad, there's a little bit less distance there, but it seems like I mean the distance is the same there, but there's less of it, so this is crooked as well, I think. And it's just overall very, it sort of has a bit of a handmade feel to it. It's not very clean or tidy, and there's some really sloppy stuff going on here. You can see, if I can get this to focus, inside there you can see a bit of metal sort of scraping bits where the drill has gone through, and that means that this horizontal cut has been made first, and it's not a very good cut either. It's kind of curved, so this almost looks like it's been done by hand or something. And then the drill has been drilled through afterwards, which I would imagine if the drill is pressing on this after it's been cut, I can actually move this a little bit just by squeezing it. Might be hard to see in the video, but I think it's moving a little bit. That means that as the drill pressed down on here, this would be moving as the drill moved into the second part of the block. So it's just a really, really crappy construction, and I couldn't use it. It wouldn't fit onto my plate, so I got one of these which has absolutely no problems whatsoever. Everything fits perfectly and it's the right dimensions and so on, and that cost me another $13, but I think it was well worth it. There was just no way I could have really managed to modify this one to be usable, I think. I'm just giving this motor a quick test with the power supply to see how it works and how noisy it is, because a lot of people in the comments on the product listing said it was really, really quiet, and it is pretty quiet. So let's have a listen to that. So obviously all the way to the left is off, and then turn it around. It's seems to be very well balanced. I can barely feel any vibration at all, and like one commenter said, most of the noise is coming from the fan, which somehow is actually blowing air quite strongly in this direction, even though those blades in there seem to be vertical. I'm not sure how that works. That's probably about, oh, that's full there, yeah. I can feel just a tiny little bit of vibration, but almost nothing really. I'm just coming back to one point that I didn't quite understand before, and that is how to control the spindle to turn it off and on. And in one of my earlier videos I was using the SPNEN pin there, which is spindle enable, and it didn't really do anything for me. It was always at positive 5 volts. The coolant enable did work, so I looked into this a little bit more and figured out what the problem was. And basically some of these pins have been rearranged to be different functions in the version of Gerbil that I'm running on here. So while I'm looking at this, I'll also look at the end stops, and we can see in the serial monitor the status of these if we want to, although we have to do a little bit of changing of some settings. So let's have a look at that. Where's my thing? Okay, so if I do $$ here to print out the current, and I can do question mark to print out the current status. Yeah, so but the default status that it shows you is the machine position and the workpiece position, and we can change that by setting this status report mask to include more things. So as you can see, we have a bunch of zeros, and then we have a 1 and a 1, and I'm presuming this is like machine position, work position, one or the other. So if I set this variable to be 255, in other words, every bit will be set, then we'll be able to get all of the status that this thing can show us. So 10, equals 255. And then if I do a question mark now I get a few more things. So I've got machine position, work position. I think this is how many commands are in the buffer that are waiting to be processed. How many commands have been received overall? I don't know what that is really. And then this one here is what I was going to look at. This hopefully is on the screen. It's the bit flags for which limit switches are currently hit or enabled, active, or whatever you want to call it. So nothing's enabled now, but if I take a little jumper and connect, let's see, I'll connect X minus. There are actually 6 pins on here for jumpers, so we've got X, Y and Z, plus and minus of each one, but each axis is joined together, so the X minus and X plus are the same pin as far as I can tell, and it just decides which one it's hit judging on the direction that it was travelling when it hit it. So if it was moving up in the x-axis and it hits a limit, it should be the X plus limit switch. Anyway, if I do question mark again there, now we can see that 001 shows us that the x-axis limit switch has been hit. And you get the same thing for Y, and this is where I just decided that I was going to have to look into this a bit more, because I tried this on the Z-axis, which is there. Okay, that's on Z. But now when I do status report, it doesn't detect that the Z-axis limit switch has been hit. It's still all zeros. So to make a long story short, I looked around on the site where the main info page for this Gerbil shield thingy, and although it doesn't say anything about this in the main part of the page, I looked through all the comments. There's quite a lot of comments. I just searched for Spindle, and at some point down here there was the answer. So this is what I needed to know. There was a change made somewhere along the way. So now the Z limit inputs are on Spindle. Oh, sorry, hang on a minute. So Spindle control is now on the Z plus and minus. Well, it's the same pin. And the pin that's labelled Spindle enable will be Z limit. So they've swapped those around. So if I connect this jumper across the Spindle enable pin, like that, and then I check my status again, now we have a bit set in that one. So I guess it's Z, Y, X in the sort of the opposite order that you might expect. But anyway, that limit switch input is working now. So then I thought, alright, now I know how to control the motor speed PWM as well, because it says the Z plus is now Spindle PWM. So I got my oscilloscope and put the probe onto the Z pins, and let's use Z minus. So there's nothing on there now, and to turn the spindle on we do M3, and that still gave me nothing. So I kept doing what I was doing, which was working, and that is to look further down these comments, and where is it? Somewhere else down here it says you also have to say what speed the spindle should be running at. So to activate the PWM function, set the S command to 0 to 1000. So that's what we need to do as well. So let's try that, and I'll just get my windows in the right place. So 0 to 1000, if we put it right in the middle at 500, now we can see it's a half duty cycle. So if we do S0, we can turn it off. S250 will be a quarter, and so on. So S1000 will be full speed. So that's how you do that, I guess. And then you can turn it off with spindle speed 0, or M5 I think was to turn the spindle off. Yeah. So let's set the speed at 500. 3 to turn it on, M5 to turn it off. Yeah. So that's how I'm going to control, hopefully I'm going to be able to control the motor I don't really care about the speed too much, but it would be nice to turn it on and off using the automated, driver like that. So here's the controller for the spindle speed. The default one is a potentiometer that you turn, as we saw before, and I was hoping that this would be a 5-volt logic or 5-volt high level potentiometer, but unfortunately it's not. When I check the voltage that we have on here, red being positive and black being ground, it's about 2.5 volts. And when it's off, completely off, so now I have my positive onto the yellow wire, which is the wiper of this pot. So I can turn the pot up and we'll get a value between 0 and 2.5 volts. So there's probably some way you could fairly easily put a resistor in here to make it so that you're using 2.5 volts instead of 5 from your from here, from the spindle controlling PWM. But I think I'll just stay on the safe side and I'll just use this manually for now and see how that goes, and maybe later I'll come back to perhaps automatically trying to control the spindle speed. Actually, on second thoughts, it's really easy to do. All you need is a voltage divider with equal resistors. So I'm just using 220 ohm resistors to do this, and it'll take that 5 volts. Actually, I'm guessing it wasn't actually 5 volts because half of it is 2.3, so maybe it was more like 4.6. Let's see, what was that voltage on there? Yeah, so it wasn't quite 5 volts anyway. The 2.3 should be enough. So I'll have the PWM coming out of here, that'll be ground and PWM, and I'm just going to try replacing this this potentiometer with this input, and I'll hook the motor back up and see if we can control it using the G-code commands. Okay, that's everything hooked up there. Now let me just make doubly sure that my spindle is not going to be on when I turn on the mains power. One thing I am interested to see is how much of a kick it gets when it turns on, if it's turning on at full speed immediately, but I don't really want to see that immediately just now. I'd rather start off a little bit slower. Okay, that's not correct, is it? Something wrong. Ooh, hate that smell. Those resistors just blew right through. One of them did anyway. The top one, that's the positive voltage side. That resistor just completely blew out. Why is that? So both of those resistors blew out. That's not a good sign because maybe we've damaged this now. Uh-oh. That's pretty strange too. Why would these wires be burnt out there? Probably broke this as well. Look, it's burnt up in that part. In there. What the hell? Why? So I've been doing a little bit of damage assessment. Fortunately, the spindle itself and the power supply for the spindle seem to be perfectly okay, which is good because that's kind of the expensive stuff. But this Arduino that was in there is completely toasted. Nothing to see, but it's just completely dead. And this, I'm not really sure what's going on here, but none of these driver outputs are turning the stepper motor anymore. And they all get warm. They get a little bit warm just from the USB power, which they never used to, and then as soon as I plug the battery in and turn that on, then they start to get, or one or two of them start to get really warm really fast. So I think in the interests of expediency, I'm just going to buy, because I can't really tell what exactly the problem is, but I'm thinking maybe all of these stepper drivers are stuffed. Probably the main board here is okay, I'm guessing, but I'm going to get one of those anyway because they don't cost too much, and the fuse in there is okay as well, so it's not a problem of that. But yeah, basically everything that was here is dead. Well, this Arduino is another one, of course. So that's unfortunate. Won't be able to do any more testing of moving the CNC around for a while. Alright, so I put all the stepper motors back on, and now we have a bit more tidy cable routing, so everything's coming together here. And I might make a sort of a board to put the control panel and the power supply and stuff on over there. The next thing that I wanted to do was use this, what do you call that thing? Dial indicator or whatever, to see how flat or how well the carriage here is following the surface of the table. So this is just a little thingy there which will move around like that, showing you to within 1/100th of a millimeter accuracy how far above this position is. So I was going to move it around and see, from distance, from the extents, how far up and down it goes on each axis. And also put the spindle in and mark where the center of the spindle is going to be in each extent as well, just sort of mark it down so I know where it's going to lie. Unfortunately I can't do that now. I suppose I could do it by turning everything by hand, but that's kind of arduous, so I might not bother. And I've got some of this MDF from Mitre 10. That's 30 centimeter squares. They cut it for me, which is quite nice. And this is going to be, most of them I thought I would use as wasteboard. It's 12 millimeter, and it can't be too high because there's only 2 centimeters between the bottom of there and the table, so that's only 2 centimeters, and that may seem very low, but that was my intention. I wanted to keep everything as low down and close to the working surface as I could to try and reduce the amount of torque that's placed on these 2 rails, which are incidentally fairly easy to move, especially if you grab it from the top. Oops, can't quite see that, can you? If I grab it all the way up here and move it, it's actually quite easy to move. So I'm hoping that because the torque will be placed or acting on here, which is a little bit closer to the rails, probably not going to be so bad from this position. I can still move it though, so that's not great. As far as putting down these boards, I thought I might drill and tap a hole at each corner once I figured out where it should go, and countersink the holes on here and have it in nice and flat. And I might just use one of these pieces to start making a board to put all the components on for the control box, or whatever you want to call it. And once again, it looks like my calculations have turned out quite nicely, because the bottom edge of the motor, when I get it to the right sort of position here, the bottom edge of the motor is just sticking out below the bottom of the clamp. So that means that all the force that's going to go into here is held steady as close as possible to that point there. And it doesn't matter if the top part of the motor sticks out a lot, that's fine. I was a bit bored, so I did actually turn this all by hand to see where the spindle's going to end up at the extents of movement. So that's what this marker pen is on here. And it's 24 centimeters by 23 centimeters, so it's almost a square. And that's leaving 0.5 centimeter at each end for just a bit of space, and also because the limit switches are going to have to be there. I don't think I'm going to be able to manage to get the limit switches to have only a 0.5 centimeter of leeway there. So this actual working area is going to be a little bit smaller than this eventually, I think. So this is where the wasteboard's going to sit there, and I'm still bored, so I think I might just go ahead and make some holes in this and also in the plate below and mount it on there using these countersunk screws like that, which I measured to perfectly fit so that they don't stick out under the bottom of the aluminium. There we go, now we have this piece of MDF stuck on there very, very solidly. Unfortunately, I screwed up one of these holes. I drilled a 5mm clearance hole instead of a 5mm tap, so had to drill another one next to it, and now I've got 2 holes here, so that's 5 holes to block up if I ever want to have a waterproof base on here. I'm still bored and I kind of wanted to see this do something before I finish for the night. So I plugged it in and it's ready to spin. Seems like the tip is moving a little bit more than I thought it would. But anyway, I'm just going to move this pencil across underneath. It doesn't quite fit under. So hopefully it'll cut through it. It's a burr kind of a bit, so it's probably not the best for this, but let's see what happens. Sounds like it's vibrating, eh? That's full. Sounds like there's some vibrations in it. It kind of looks like it's moving. It's not very good, is it? Or is it just the way it looks with the curls on the cutting surface? I don't know. Oh well, let's see what it does to this pencil. Nothing. It's spinning the wrong way, isn't it? Doesn't feel like it's rotating perfectly smoothly. It's a bit of vibration or something. But it did a much better job of cutting through this though, when it's turning the right way. That's more like it. Okay, that was a little bit dodgy. I think what happens there is the vibrations is gradually moving the z-axis down because the motor's not on, so it's not holding it there. So each time I tried to do a cut here, I cut further and further in until that last one I was actually cutting into the graphite inside the pencil. Almost couldn't get it out. So let's not do this anymore, but we can see that it cuts reasonably well. I mean, I think that nasty noise from the vibration, that vibrating kind of noise, might just be the lead nut screws that are sort of wobbling around. But see, this bit here was when the z-axis was not slipping down. That was quite good. That's what I was trying to do again on camera just now, but it ended up like this. See how the last 2 rows are just getting deeper and deeper? I think most of this noise is coming from that lead nut inside there. It's just a little bit loose. And when it's not pressing up against the thread properly, it vibrates. I've ordered some of those lead nuts that have the spring anti-backlash thing, so I might try those. That probably will get rid of this problem, I hope.